Let's solve this physics problem about two boats moving in a river with a current. Let's start by visualizing this problem. We have a river with a buoy anchored in the middle. Two boats start from the buoy. Boat A moves along the river, while boat B moves across the river, perpendicular to the flow. Let's define the velocities and distances in our problem. Let V be the velocity of the river current. According to the problem, each boat has a velocity with respect to water that is 1.2 times the stream velocity. So the boat velocity relative to the water is 1.2 v. Boat A travels along the river. When it moves downstream, its velocity relative to the shore is boosted by the current, giving 1.2 v plus v, which equals 2.2 v. When returning upstream, the current works against it, so its velocity relative to shore is 1.2 v minus v, which equals 0.2 v. For boat B, which moves perpendicular to the current, the situation is different. Its velocity relative to the water is 1.2 v, but the current pushes it sideways at velocity v. Using the Pythagorean theorem, the resultant velocity is the square root of the sum of the squares of these components. Now, let's animate the boats' journeys. Both boats start at the buoy and travel the same distance d before turning back. Boat A travels downstream at speed 2.2 v. It then returns upstream at the slower speed of 0.2 v. Boat B travels at a constant speed of square root 2.44 v in both directions, but its path forms a bent line due to the current. On the return journey, it has to angle against the current to reach the buoy. Let's now calculate the ratio of travel times. For boat A, the time to travel distance d downstream is d divided by 2.2 v. The time to return upstream is d divided by 0.2 v. So the total time for boat A is the sum of these, which simplifies to 11d divided by v. For boat B, the speed is constant at square root of 2.44 v. So the total time for boat B is 2d divided by this speed, which gives 2d divided by square root 2.44 v. Now we can find the ratio tau A divided by tau B. This simplifies to 11 divided by 2 times square root 2.44, which equals 3.52. In summary, we've solved this riverboat problem by analyzing the motion of each boat and calculating their travel times. Due to the river current, boat A experiences dramatically different speeds when traveling with or against the current. Meanwhile, boat B maintains a constant speed but follows a curved path. The ratio of travel times, tau A over tau B, is 3.52, which means boat A takes significantly longer to complete its journey. This demonstrates how river currents can dramatically impact travel times, even when boats travel the same distance.